Good morning, students. So let's start with today's Google Classroom. So today's Google Classroom it is about the paper name. It is organic chemistry, and the paper number is 7. And the name of the chapter is phenols. Topics are we have to discuss today's are reactions with a mechanism, intermolecular price rearrangement, then Claisen rearrangement. So today we have to discuss the reactions, some reactions or the two reactions with the mechanism. So first is intermolecular price rearrangement. Then second is Claisen rearrangement. So first start with first rearrangement, that is intermolecular price rearrangement. So what is meant by this intermolecular price rearrangement? So what is the reaction and how the reaction goes, or what is the mechanism of the reaction? So we can see one by one. So price rearrangement, it is named for the Gattermann, German chemist. Theophil Price. The Price, it is the name of the scientist. From the name, so this reaction is name of the reaction is given. So what is this intermolecular price rearrangement? This price is a rearrangement reaction of the phenolic esters to a hydroxyaryl ketone by catalysis of Lewis acids. It involves migration of the acyl group of the phenol ester to the aryl ring. Simply, the price rearrangement, it is a reaction of the phenolic esters. Phenolic esters are converted into the hydroxyl aryl ketones, and the catalysis used in this reaction, it is Lewis acids. Lewis acids, it may be the AlCl3 or the ApCl3. So in a rearrangement, how the rearrangement rate takes place? There is a migration of the acyl group from phenol esters to the aryl ring. So there is formation of the hydroxyaryl ketone takes place. So it is a reaction. Then see the mechanism, how the mechanism is carried out, or the mechanism is done in this price rearrangement. In a first reaction step, Lewis acid, for the instance aluminum chloride AlCl3, it is a Lewis acid, coordinates to the carbonyl oxygen atom of the acyl group. Acyl group oxygen atom is coordinate to the AlCl3, there is a Lewis acid group. This oxygen atom is more electron rich than the phenolic oxygen atom and is a prepared Lewis base. This interaction polarizes the bond between the acyl residue and the phenolic oxygen atom, and the aluminum chloride group rearranges to the phenolic oxygen atom. This generates the pre-acylium carbocation, which reacts to the classical phenolic aromatic substitution with the aromatic ring. The abstracted proton is released as hydrochloric acid, where the chlorine is derived from aluminum chloride, The orientation of the substitution reaction is temperature dependent. For low reaction temperature favors para substitution, and with the high temperature, the ortho product prevails. This can be rationalized as exhibiting classic thermodynamic versus the kinetic reaction control, as ortho product can form the more stable bidentate complex with the aluminum. Formation of the ortho product is also favored in non-polar solvents. The solvent polarities increases, the ratio of the para product also increases. So let's say the reaction of this price rearrangement and the mechanism diagram. So it is a silister. It is catalyzed by the Lewis acid. There is the LCA3. There is the presence of the there is the presence of this hydrochloric acid. So there is formation of this our product takes place. So in a mechanism, the oxygen atom contains the two electron pairs. It attacks on the aluminum of the Lewis acid. It is AlCl3 aluminum. It has low electron density. So then rupture of this carbonyl oxygen and the carbon bond takes place. It removes, and there is formation of the two products. That is, it is this reaction. It is a temperature dependent reaction. So at room temperature, the carbonyl group it is transferred to the para position, and if at 370 Kelvin temperature, the carbonyl group is transferred to the orthocarbon atom. So next reaction, that is Claisen rearrangement. So just see what is meant by this Claisen rearrangement. Claisen rearrangement, it is a unsaturated ether. So on heating, so there is a formation of the unsaturated carbonyl compounds. Claisen rearrangement of the phenyl allyl ether. It is a example given, that is the transformation of the group to the from the carbon atom 1 to the carbon atom 6, or the carbon atom 4 to the carbon atom 5, carbon atom 2 to carbon atom. So depending upon the the rearrangement, it is depending upon the rearrangement, the type of the rearrangement takes place. So the tautomerization to restore aromaticity, by using the tautomerization, these structures exhibits their aromatic nature itself. So they have given the example, that is this tautomerization, this proton, it gives to the carbon single bond. So there is formation of the double bond takes place, and the alternate single and the double bond formation takes place. So the aromaticity of this ring restore. Aromaticity is also the restore, and there is formation of the final product takes place. Thank you.